All right, today we will be looking at Math 201 Introduction to Mathematical Method. Introduction to Mathematical Method. All right, and so the first thing we'll be looking at is the function of several variables. The functions, a function of several variables, right? A function of several variables. So we find out along the line that many functions depend on more than one independent variable. So independent variable, we'll talk about independent variable. We'll talk about dependent variable. Dependent variable. All right. Before we go further, I'd like to explain what each of these terms mean. So when we say a variable is independent, the word independent there, independent, connotes freedom, right? The word independent connotes freedom. It means it can stand on its own. It can stand on its own. The word dependent means it is relying on someone else, on something. It is relying on something, right? So that is why we say something is independent. It means it has freedom. It can stand on its own. Something is dependent, or a function or a variable is dependent. It means it has to rely on something. Let's say, for example, we have V is equal to 2RH. Let's say, for example, V is equal to 2RH. Now, this here is a constant. Why is it a constant? Because wherever you go in this world, 2 is always 2. If you go to America today, 2 will be 2. If you go to Japan, 2 will be 2. So it's a constant, right? It's just an integer. It's a constant, right? But when we have R and H, now, do you know that these people here are independent variable? They are independent variable. Also, this guy here is an independent variable. Why? Because the value of V is dependent on what the value of R and the value of H is, right? Let's cite an example. You would not know the volume, you would not know this V if you don't have a value for R and H. That is why we said this R is an independent variable, which means it can stand on its own. The dependent variables are variables that need to rely on something. So this guy here is a dependent variable. Did you see that? It's a dependent variable, which means that this guy needs to rely on the value of R, and it needs to rely on the value of H to function. All right? It needs to rely on the value of R, and it needs to rely on the value of H to function. That is why we call it a dependent variable. Let's cite an example. So given that R was 2 and H is 5, then we can be able to calculate the value of V. Then we can now say that V is 2 into the bracket of 2 into the bracket of 5. It means that 2 times 2, which is 4, multiplied by 5, which is 20. It means, what it simply means is that the value of V has been revealed. Why? Because the value of H was given, the value of R was given. So it means these two people are what holds the existence of V. Did you see that? The values of R and H are what holds the existence of V. All right? So as we progress into the calculation, we discovered that a function f can contain many independent variables. For example, a function can contain this 2xy plus y squared. This is a function. What it simply means here is that this particular function, has two independent variables. So this x and this y are present in the function, so they are independent variables. So the independent variable here, are x and y. Did you see that? The independent variable in these systems are x and y. So a function containing two independent variables, x and y. Why are they independent variable? They are independent variable because you cannot know the value of f, the function itself, if you don't have the value of x and y. So let's say for example, we have x to be 2, x to be equals 2, and we have y to be equals 1. It means that this function will be 2 into bracket 2 into bracket 1 plus 1 all squared. And so we're going to have 2 times 2, which is 4, plus 1, which is 5. So the value of the function itself, the totality of the function, is depending on the two independent variables you see in the system, which are x and y's. So let's assume you have a function containing x, y, z. You have it as 2x squared y plus yz. Yes, this is a function having three independent variable systems, right? Having three independent variables such that 2x squared y plus yz is a function. All right, so it is important for us to note that the number, take note now, the number of independent variable, in a function tells us the dimension of that function. So the number of independent variables present in a function tells us the dimension of that function. And so what do we say? We said, for example, if we have a function containing y, x, y, and z equals 3x squared y z plus z cubed. It means the dimension of this function is 3. Why? Because the number of independent variable in the system is 3. Did you see that? So the number of independent variables present in the system tells us about the dimension of that system. Okay, now we've been introduced to functions. We've been able to understand independent variables. We've been able to understand dependent variable. It is time for us to talk about domain and range. Domain and range. Did you see that? So we are left to ask a question. We said, what is the domain of a function? What is the domain of a function? We said that the domain of any function is the totality. The domain of any function is the totality. Totality. The domain of any function is the totality of all points. The totality of all points for which, you see that? For which the function is defined. For which the function is defined. So the domain of any function is the totality of all points for which a function is defined. What does it mean? It means every point that makes a function make sense is called a domain, right? And we said functions may come in different varieties. We have functions and we have their varieties. They come in varieties. We have functions and we have their attitudes. What make a function defined, right? For example, let's find the domain. We want to find the domain of w equals the square roots of y minus x squared. Now, if I ask you this question, that what is the dependent variable in this system, what you're going to be telling me is that the dependent variable, for the sake of this video, we'll be calling dependent variable dv. So what are the dv's in this question? The dependent variable is w, because w is waiting for the value of y and x to survive. So the dependent variable is w. And what are the independent variable? iv is y and x. True or false? Okay. Now that we have been able to state this as a foundation, what can we say is the domain of the function? So we said, when a function, this is the attitude of square roots, right? You say when, now the law states that when a function is under a square root, when a function is under a square root standing as a numerator, then the function will be defined. The function is defined when you set it greater than or equal to 0. The function is defined when you set it greater than or equal to 0. Why did we say that? Why did we say the function is defined when we set it greater than or equal to 0? Let me explain. The reason is because on the number line, if we have 0 here, we have 1 here, we have 2, we have 3, we have -1, we have -2, we have -3. Whenever we take the square root of a function, say for example, if you take the square root of 0, you have an answer. You have 0 as an answer. True or false? True. If you take the square root of 1, you have an answer. Right? If you are approaching the positive side, you will have an answer. If you take the square root of 2, you will have an answer. If you take the square root of 3, you will have an answer. The only problem you will begin to have is when you try to take the square root of a negative number. Say, for example, you are taking the square root of -1. You begin to have a problem. This is resulting to a complex number. When you take the square root of -2, this will result you to a complex number. You'll be having something like 2i, whatever. So you begin to have your problems when you cross this boundary. when you cross the boundary. And so we said that for a function to be defined, as long as it's under the square root, like this, standing as a numerator, you know, this function square root of y minus x squared is the same thing as this, right? Because this is the same thing as this. Anything divided by 1 is that thing. So whatever divides 1 is whatever. So we now said, as long as it's starting as a numerator, the function is defined when it is greater or equal to 0. So what we're going to write here, we're going to write let me repeat the question again. W equals the square root of y minus x squared. What we are going to be writing here now is that the function, let's give the statement. The function is defined. The function is defined if y minus x squared, whatever is under the square root, whatever functions we have under the square root. So the function is defined if y minus x squared is greater than or equal to 0. Did you see that? Y minus is greater than or equal to 0. So now that you have been able to state, the law that guides the square root function like this, then you have the privilege to recite the domain. It means that the domain of this function W is, now watch how I wrote the domain. You see, you can write it like this: x comma y. Why did I say x comma y? I'm listing out all the independent variable in the system. The independent variable in this system is y and x, so I'm listing it x and y alphabetically. So we said x comma y, which are elements. Did you see? X comma y, which are elements. This E means elements. X comma y, elements of all real numbers squared. Why did I put squared there? The squared is telling me the dimension. So what is the dimension of this equation? Because it has two independent variables, x and y. So I said x comma y, element of all real numbers squared, such that, did you see that? Such that y minus x squared is greater than or equal to 0. Did you see that? Did you see that? Why were we able to arrive at this answer? We're able to arrive at this answer because we have known what makes this function defined. We have known that the laws that guide the square root function is that whatever is under the square root should be greater than or equal to 0. Not in all cases, right? We have several other cases which we're going to treat as time goes on. So we said the domain of the function is x comma y, element of all real numbers squared, where this squared here you're having here reports the dimension. And what is the dimension? The number of independent variables present in the system. Is that clear? And so we have been able to establish that this is the domain of the function. And so from here we ask ourselves, what is the range? What is the range? So to get the range, you must notice that the smallest value that W can produce. So domain is input. Let me put that here. Domain, all inputs that makes a function defined. Range, all outputs. Range, all outputs that a function can produce. All outputs that a function can produce. All right. So we said the range of the function, we'll ask ourselves to get the range, what are the values, or what is the smallest value that this can produce? Remember, our illustration was that this is a number line. And we start from 0, we start from 1, 2, as we approach positive infinity. And the number line, when you are labeling 0, 1, 2, positive infinity, minus 1, minus 2, as we approach negative infinity. Correct? Correct. So we said that to find the range, when you find the square root of 0, what do you have? 0. That's an output. I told you that square root doesn't like a negative integer. You begin to have problem when you are treating square root, when you start from here, backwards. So we are looking at the positive numbers. So square root of 0 is 0. Square root of 1, you have an answer. Square root of 2, you have an answer, perhaps 1 point something. Square root of 3, you have 1 point something, and so like that. You keep generating answers as long as you do not come to this negative part of the table, of the number line. As long as you don't cross your boundary and come to this negative part of the number line. So what will be the range? What is the smallest number that this function can produce from this law? Is 0. You see, we are treating just the positivity, the positive part of the graph. So it's 0. And 0 to where? You see, this number keeps going. It keeps going, keeps going, keeps going. If you do the square root of 4, you have an answer. If you do the square root of 5, you have an answer. In fact, if you do the square root of 1000, you have an answer. Valid. It's defined. It's defined because you said greater than or equal to 0. So the range of this function will be from 0 to positive infinity. From 0 to positive, it means that we are valid when we start from 0, positive numbers only. So from 0 to positive infinity. And how do we report this on the domain? So when we have this kind of circle, this kind of brackets, this bracket, you can use it for infinities. Infinity. Either positive infinity or either negative infinity. But whenever you use this bracket when you are reporting a number 1, 2, 3, 5, 10, 0, and the rest. And so we say that the range of this function is from 0. Did you see that? Why am I using this bracket? I'm using this bracket because it constitutes, or it is the right bracket to use when you are dealing with integers, numbers. So we say 0 to positive infinity, and because I'm dealing with infinity here, my bracket will be like this. So this is very correct. I think we should watch out for this, because as time goes on, you will be solving CBT questions and you will be seeing a template like this as an option. Your Maths 201 is a CBT exam, and so there are possibilities you'll be seeing this as option A. What if you see this as option B? What if you see negative infinity, positive infinity, comma 0 like this? Would you have chosen this answer? No, this is wrong. Because no, first of all, you don't use this bracket to report an infinity. Rather, you use this bracket to report infinity, positive infinity. So the range of this function is from 0 to positive infinity. All right? Okay. So I believe we understood the procedure. Let's look at another sample. Question number 2. Question number 2. It says find the domain. Find the domain. You see that? Find the domain and range. And range find the domain and range of the function. Find the domain and range of the function f x comma y, a function containing two independent variables. A function containing two independent variables equals the square root of, did you see that? Square root of 9 minus x squared minus y squared. So how do we solve this problem? We say the function is defined if and only if 9 minus x squared minus y squared is greater than or equal to 0, since we are dealing with the square roots. And so we say that if the function is like this, then we can easily say that 9 is greater than or equal to, so we take this to the other side, alright, so we have 9 greater than or equal to x squared plus y squared. I hope you know, whenever you are taking this to the other side, it changes signs. So a negative becomes a positive, and so you have it that way. And so if Ade, for example, is greater than or equal to Bola, is the same thing as saying Bola is less than or equal to Ade. Did you see that? And so when we find out that it is like this, we can easily say that x squared plus y squared is less than or equal to 9. The same thing. So let's report the domain. The domain of this function f is, did you see that? The domain of this function f is, let's list out the independent variable present in the system, x comma y, did you see? Element of all real numbers squared. Why? Because the total number of independent variables present in the system is 2, x and y. So x comma y, element of all real numbers squared, such that x squared plus y squared is less than or equal to 9. Did you see that? The domain of the function. And so what will be the range of the system? What will be the range of the system? The range of the system is, remember, we are dealing with a square root, right? We are dealing with a square root. So let us assume that this whole functionality here is 0. Let's assume that. If we assume this, it means we are dealing with 9 minus 0, square root of 9, which is 3, right? Let's assume that let's treat everything here as 1. So let's assume that this whole functionality, x squared minus y squared, let's assume that it is 1. So 9 minus 1, square root of 8, that's an answer. 9 minus 2, let's assume that it is 2, that's an answer. That's square root of 7 is an answer, is valid, is defined. Let's assume that we have square root of 9 minus 8, which is square root of 1, which is 1, is defined. The only time we begin to have problem is when we say 9 minus 10, which is square root of minus 1. So we are wrong at this point. So we start from the place where we began to make sense and stop at the place when we stopped making sense. So the range of this function is from 0 to 3, right? From 0 to 3. So we began to make sense from here. Square root of 9, which is square root of 9 divided, that's 3. Square root of 8 is an answer. Square root of 7, an answer. In fact, the square root, we do this up to the square root of 9 minus 9, which is the square root of 0, which is 0. Right? The only time you begin to have problem is when you say the square root of 9 minus 10, a number greater than 9. So you have the square root of minus 1, and we don't want this. Why? Because square root does not like negatives. Square root does not do what? Does not like negatives. So we started making sense from where? From here. This is the lowest number. from 0, and we stopped making sense at this junction 3. So we said the range of the function is 0 to 3. Did you see that? Introduction to mathematical method. Introduction to mathematical method. Again, let's look at some very simple, let's look at some simple questions again. Let's look at some simple questions again. Question number 3. Question number 3 is that find the domain and range. Find the domain and range of the function. Find the domain and range of the function. We have f x, y. That's a function containing two independent variable system is equal to x plus y over the square root of 16 minus x squared minus y squared. We want to find the domain and range of this function, right? Now, because the square root function is serving as a denominator, so there is a law. When the square root function is standing as a denominator, this time around is not on the numerator. You said, note when a square root function is serving as a denominator. When a square root function is serving as a denominator, it said the function is defined if the function is defined if 16 minus x squared minus y squared is greater than 0. So basically what we are saying is whenever we have a square root function standing as a denominator underneath, so we said the function is defined when the function is no longer greater than equal to, right? No longer what? Greater than or equal to. So imagine we have, for example, this whole totality is 2. 2 divided by the square root of minus 1. That's a problem. That's an error. That's a problem. So in fact, 2 divided by the square root of 0. That's 2 divided by 0, still a problem. So it is necessary for it to be greater than 0, not greater than or equal to 0, because we are avoiding this error. 2 divided by 0 is an error on your calculator, right? So we said whenever we have a function like this, let's set the function in the denominator to be greater than 0. And so we find out that when we set this to 0, then we're going to have 16 is greater than x squared plus y squared. Why? Because we are able to move these to the other side, from the left hand side to the right hand side. So 16 is greater than x squared plus y squared. Greater than x squared plus y squared. So for the fact that we want to be decent, we want to write the variables before the constant. The variables before the constants. Variables before the constants. So we said x squared plus y squared is less than 16, right? So the domain of the function is x, y, element of all real numbers. So tell me, what will be the dimension? The dimension is 2, because we are dealing with two independent variable systems. So we said x, y, element of all real numbers squared such that, did you see that? Such that x squared plus y squared is less than 16. Is less than 16. Did you see that? So, having said that, what would we have as the range? What will we have as the range? The range of the function is all real numbers R. Why is it all real numbers R? You need to know that any number you slot in here will produce a value. If you like slotting negative, it's going to produce a value. If you slot in negative, you have a value. Plus slotting positive, you have a value. X plus y, 10, 15, 20, 100, you have a value. The only difference or the only stoppage you have is when you try to put a number greater than 16 here. Let's assume the totality of this is 17. So you have 16 minus 17, which is minus 1. Square root of minus 1 is a problem. And so we have treated that here already. We have said that the function should be defined when 16 minus x squared minus y squared is greater than 0. So we are assuming from here that this value here is greater than 0. And so when it is greater than 0, then you can flow. You can have all real numbers. So the range of the function is all real numbers. All right. Again, it's a wonderful time to have introduced the Maths 201, the domain and range. We've been able to talk about independent variable. We've been able to talk about dependent variable. We've been able to satisfy or talk about dimension, right? So see you in the next class.